Hi everybody, let's go ahead and talk about net ionic equations. So if you look at the example here, this should look pretty familiar to you as kind of a generic double replacement reaction. A little bit of the difference is that we're starting to realize that many of these ionic solids, as you now know, many of them are in aqueous solution. So in terms of what a net ionic equation is, it first helps to look at like a normal balanced equation for this reaction, where my two reactants, sodium phosphate and calcium chloride, are both ionic substances in aqueous solution. And I form two products. One of them is sodium chloride, salt, which we know is soluble in water, goes into aqueous solution. And the other one is calcium phosphate. And again, you could write this equation and the formulas and balance it, no problem. What we're really going to focus on in this unit, in our solution chemistry unit, is what happens to the form those products take when I have two aqueous solutions that I combine together. So in the big scheme of things, a net ionic equation, as you can see from this definition, is showing only the particles participating in the reaction. All of the extra ions, what we would call these spectator ions, are things that just sort of sit back and watch the reaction happen. And they're ions that stay in aqueous solution. Nothing too exciting happens. So the next step, and we're going to summarize these steps in a minute, after I write and balance that first entire molecular equation, my next step is going to be to write the complete ionic equation. And it's showing all the particles as they exist in solution. So I have a total of 2 times 3 or 6 sodiums in aqueous solution. I have 2 phosphates, 3 minus, in aqueous solution. I have 3 calcium, 2 plus, in aqueous solution. I have 3 times 2 or 6 chloride, minus 1, in aqueous solution, etc., etc. The next thing I'm going to do then is pick out those spectator ions, the ions that are sitting back and watching the reaction. And as you're taking notes on this, the way I determine those is the ions that on both sides of the reaction, they're ions that stayed in aqueous solution in the same number, in the same form. So sodium, 6 aqueous plus 1 sodiums on the reactant side, and I have 6 plus 1 sodium aqueous on the reactant side. So I've crossed those out. Chlorine, I have 6 minus 1 chlorine on in aqueous solution on the reactant side, and I have 6 minus 1 chloride in aqueous solution on the product side. The calcium and the phosphate form a solid precipitate. And so all of the ions that stay in aqueous solution, that just sit there and don't really do anything, they're spectator ions, and I cross them out. My net ionic equation then, that word net means leftover. So what ions are left over after I've crossed out those spectator ions? And I write my net ionic equation with only those. So it would only be, on the reactant side, the 3 2 plus calcium and the 2 PO4 3 minus. They started out in aqueous solution on the reactant side, but as a product, they formed that solid precipitate. So the question you're now probably asking is, okay, that they were in aqueous solution, remember? So the way I remember was, I think it was calcium phosphate. How I knew that calcium phosphate stayed as a solid precipitate, formed a solid precipitate. Kind of makes sense, but how do I determine which of those things are in aqueous solution? In other words, which are the spectator ions and which things are going to form the solid precipitate? Those are the things that are represented in the net ionic equation. So if you don't have your chem helper handy, and realize that there is an electronic copy of it. I think it's in the gas law unit at the top of the module. I think it's gas laws. There's an electronic copy of it. But you want to be looking at this chart right here. So based on that equation that we just went over, notice that the spectator ions, those are the things in red, that was the sodium and the chloride. Both on the reactant side, they were in aqueous solution, and on the product side. I know that they stay in aqueous solution as I look at my solubility chart at the top of the chem helper, and I can see here are the halides like chloride, bromide, and iodide, and it says most halides are soluble in water. These are the only halides that are not soluble, that are insoluble, okay? So sodium chloride is going to be soluble in water. It's going to stay in aqueous solution. My other product, so when I look at these phosphates, most of them, except for like this exception right here, most of them are insoluble in water. And that's so let's go through and do a couple of examples. Lead nitrate plus potassium iodide. So let's start by writing that equation, just the regular old normal equation. I'm just going to write that AQ. I'm probably going to get a little sloppy there so you know what I'm writing. Should be PB I2, and that is going to be the solid. So potassium nitrate. When I look at my chart here, let's see, here are my nitrates. All nitrates are soluble. That means that that's going to stay in aqueous solution. Here's my halide, my iodide. Now remember, most of them are soluble, but there's a lot of these metals that are not. So the lead iodide is insoluble. That formed the solid precipitate. Now I'm going to write this out in the entire ionic equation so that I can cross out those spectator ions. Sorry. Okay, I'm going to switch my color here for a second. So now I want to look at what things stayed in aqueous solution. And let's see, my lead started out aqueous, but it ended up in that solid precipitate. So that's not a spectator. That's one that's going to be represented in my net or my end final ionic equation. Here's a nitrate ion. Oh, that nitrate ion was in aqueous solution, and it's in aqueous solution down here. So that's a spectator ion. I cross it out. Here's my potassium ion in aqueous solution on the reactant side. My potassium ion in aqueous solution on the product side. I cross it out. Remember, the iodine formed part of that solid precipitate, even though the lead and the iodine started as in aqueous solution. As a result of that double replacement reaction, they precipitated out as a solid. So my net ionic equation is going to be Pb2 plus aqueous, because on the reactant side it's in solution, plus 2I minus aqueous forms PbI2 solid precipitate. Let's try another example. Sodium hydroxide and hydrochloric acid. NaOH plus HCl, both aqueous. And whenever you write these net ionics, your two reactants are aqueous solutions. That's why we're talking about it in this solution chemistry unit. And I get a double replacement reaction. So I get sodium chloride. And again, I can check here. Here's my halides. Most are soluble. The only ones that aren't are some of those transition heavy metals. I also kind of know that, oh, table salt, soluble in water. And my other compound is HOH. If I just look at it as a double replacement, I'm getting the positive hydrogen from this acid and the negative OH from that base. It's a +1 hydrogen and a -1 hydroxide. That's water. And so water is not an aqueous solution, it's a liquid. So as I look at this, and I'm going to try to like just talk through and get to the net ionic equation. So I think, sorry, I got interrupted. I think I can just kind of walk you through to get to the net ionic. So this liquid is not the same, right? So I can cross out, the liquid is the thing that participated in the reaction, the hydrogen and the hydroxide. The sodium and the chloride remained in aqueous solution. So my net ionic equation is OH minus in aqueous solution plus H plus in aqueous solution yields H2O, a liquid. Let's see, I think we have one more. Zinc plus hydrochloric acid. So this is a single replacement. I have zinc, which is a solid, and I have hydrochloric acid, which is an aqueous solution. And in that single replacement reaction, zinc, remember, bumps out that hydrogen so that I get H2 gas plus ZnCl2 in aqueous solution. And I know this is an aqueous solution because most chlorides are soluble, all except for those metals, and zinc is not one of them. So in the next step then, I'm going to cross out anything on the reactant side. Oh, wait a minute, we better balance this first. H2, yep, that's balanced. I'm going to cross out the zinc and the chloride because they went into aqueous solution. And my net ionic equation is 2H plus in aqueous solution. Oops. Yields H2 gas. And I crossed out the spectator ions, the ones that were in aqueous solution. I eliminate them from both the reactant and the product side. Good luck, guys. If you feel like you want more examples, just shoot me a message and I can walk through a couple more examples. I believe there are about 5 samples on the homework.